of the graph, and this is measured by volt. How to find R small is depending on this equation. R small will equal minus B, right, minus RA. So this is minus B minus RA. So what you need to find eta and R? You need to find the slope, and you need to find B, right? This slope and B from where? From the graph. So you need the graph. From the graph you need what? You need the values of R and you need the values of 1 over I. Right? Yeah. So here you see I am going in the reciprocal way. I go to the result, final result, and then what I need in this final result? I need this, I need the graph, I need the slope and B. From where I got the slope and B? From the graph. How to plot the graph? I need these values. This is R in ohm, and this is I in ampere. So R I will start with 100, 90, 80, 70, 60, 40, 30, and 20. From where I got this R? From the resistance box. Okay? I will get I from the ammeter. For each case, I will get I from the ammeter. So here, what's the I when I have 100 ohm? What's the I when I have 90 ohm? And so on to the end. But actually, I am not plotting between R and I. I am plotting between R and 1 over I. So when I got these values, take the reciprocal of this value. Let's say you have I 0.1. This is the I in ampere, 0.1 ampere. So what's the 1 over I? It's what? It's 10. 1 over 1.2. You get the point?
Yes. Yeah.
I mean, get this from ammeter and get this from the result of that ammeter. Clear?
Yeah.
I think it's easy. So like this, we'll do our experiment. And here, so I will plot between this. And this is on x-axis. Please don't make it on y-axis. This is on the x-axis and this is on the y-axis. Because some students make it on the...
Crazy.
This is x and this is y. No, this is x and this is y. Clear?
Yeah.
So, I will go to the practical work and how to connect my circuits. Okay? Okay, so what we have the resistance box. This is the resistance box. I will start with 100, right? So this is 0, 0, 0, 0. We said always make it on 0. And then this is 10. And this is 1, 10, 100, and 1 kilo ohm, right? So here, see, this is 1, 2, 3, 4 to 10. So 10 by 10, this is what?
100.
This is 100. So I will start with 100. As I said, here as you see, I will start with 100 ohm. So I will put it on 100 and then on this is 90 and then this is 80 and so on. Okay?
Yeah.
So I prepare my resistance box on 100 ohm. Clear? Okay, this is my resistance box. I will prepare my ammeter. When I put it on 1 ampere, mean the maximum value is what? Is 10. This represent what? Represent 1 ampere. So this 10 represent 1 ampere. If this 10 represent 1 ampere, 8 represent what? Represent 0.8. Right? 6 represent what?
0.6.
And so on. Just to know how to read. We'll make it. Okay? So I have resistance box. I have the multimeter, and I have key, this key, normal key, okay, and I have the battery. This is the battery. Now, what's the meaning of these wires? Actually, here I have complete black, okay, complete black, and I have here a black with white. You see? Complete black is positive. This is the positive terminal of the battery. And the white, you see this white
Yes.
on the board? You see this white on the board? So this is represent what? Represent the negative value. Is that clear? So this is the positive and this is the negative value. Clear? Okay. So now I have this circuit. I have these four things. I will connect it in series. You can't put ammeter before the resistance box. You can't put resistance box before the ammeter. You can't put the key anywhere. This is your choice. Okay? I want the complete circuit. So I will start. I will use this just for, you know, just to connect it here because I needed to. So this is the positive direction of the battery. Okay? I'll put it on the ammeter and this is in positive. You see this is the positive. You get the point? This is the positive. So I'll put it here, the positive. And get out from the negative direction to the, let's say, resistance box. Okay. This is the resistance box. And from the resistance box to the key. Okay. And then come back to the battery. That's it. So I will open it. So for that you should open this. So I put it here. Okay, and I will connect it. Now I have the complete circuit. You see here, this is the battery between this and this. Okay, battery is in between this, and then ammeter, then the resistance box, then the key, and come back to the battery. That's it. This is the complete circuit. So now I prepare my circuit. What I will do now is to focus on only on the ammeter to know how to read. Okay, now it's clear, right?
Yeah.
So here I have it's clear, right? So I will start. I put it where now? On 100, right? 100 ohm. Just to keep in mind, this is 100 ohm. So I will read now the ammeter. Now tell me again. I put it on 1 ampere, right?
Yes.
When I put it on 1 ampere, I mean the maximum value is what? Is 1 ampere, right? So this can represent what? Represent 1 ampere. This 8 represent what? 0.8. This one represent what?
0.8.
0.9. 0.8, 0.91. Clear?
Yeah.
This 0.6, right? So this represent what? 0.5. This represent what?
0.2.
0.2. This represent
0.1.
what? 0.1. Okay, if this is represent 0.1, this one represent what?
1.
0.02. Yes, 0.02. 0.04, 0.06, 0.08, and this is 0.1, 0.12, 0.14. You get the point, all of you? Okay, 0.16, 0.18, 0.2. Don't forget. Okay, so I will do some trick here, just to make it. So actually this is 0.2. Okay, this is 0.4, this is 0.6, this is 0.8, and this is 1. Get the point?
Yes.
If this is 0.2, means this is what? This is 0.1. And this is how much?
0.33.
0.3. And this is how much? This is 0.02. This is how much? 0.12. Okay. In between this one, this is 0.13. In between.
Yes, yes.
Just to know how to read. I mean, I should program my mind to read this like this. I see some numbers, but actual, this is not actual numbers. I should divide it on 10. So without dividing on 10, just keep in mind, this 2 represents 0.2, 0.4, and so on. so you can take the reading easily. Okay? So now I will start my experiment. This is 100 ohm. Here I have 100. So I will get the I. Okay. And please, I forget that when you take the reading, you should take it very fast, because if you take it for a long time, this exhausting of the battery. That's why the electromotive force will get down during the experiment. And here, I suppose that the electromotive force is equal to the slope mean, and the slope is always constant. Okay? So be sure to take the reading very fast to keep your battery as constant as possible. Get the point? Yes.
What we call this box?
Resistance box. Resistance box. Okay? It's written on it. Yes. Very fast, because if you connect the circuit, okay, for a long time, this is exhausting of the battery. Exhausting. I mean, the battery will get down. I mean, your battery maybe will start with 9 volts, okay, and then after 1 minute it will be 8.9. After 1 minute it will be 8.8, and so on. But my suppose in this experiment to make eta is constant, right? When I take this very fast for some seconds, I will get also different values, but this is not that big, so I can suppose it as constant. Clear?
Yes.
And this is very important. This is very even, especially for the small resistance. For small resistance that I use like 20 or 30, you should take it very fast. Okay? Okay, we'll see it now. Don't worry. Okay, I will start with one, and please keep your mind there. Are you ready?
Yeah.
Are you ready?
Yeah.
Okay. Just keep the pointer in your mind. Where is it? Because I will remove this one. So, see it. Oh, how much?
Honey was set on 0.1.
Here, exactly here, right? It's not 0.1, it's not 0.08.
0.5.
So this is what? 0.09. 0.09. Clear? I'll put it on 9 now.
لحظة.
90 ohm. Now 90. Don't write anything, because you will do your experiment. Okay? You have different batteries. Be sure you will get different